So now we look at questions 28. The following equations represents the reactions between the potassium and oxygen. What is the maximum mass of potassium oxide formed when 19.5 gram of potassium is heated completely in oxygen? So this question, they ask you to find the mass of potassium oxide, okay, and they give you the information of potassium, the mass of potassium. So we need this formula to help us to do the questions. So you must memorize this formula. First, mass is equal to mole times molar mass. Second, volume is equal to mole times molar volume. Third, number of mole particle is equal to mole times Avogadro constant. The fourth one, mole is equal to mv over 1000. M is molarity, V is a volume. The volume here is different from the volume for the second one. Okay, the second one, the volume here is for the gas. It's used for gas. This one, the volume is used for solution. Okay, solution. This is a different for these two formulas. Now we look at the questions. For this type of calculation, you must write up the balanced chemical equation first. So we write the equations. So from the equation, we know that 4 moles of the potassium will burn in 1 mole of the oxygen, okay, to produce 2 moles of the potassium oxide. This is a balanced equations, chemical equations. Now they ask you to find the mass of potassium oxide, the mass, okay, the mass. What is the mass? And they give you the mass of potassium. This is potassium. The mass they give you is 19.5 gram. Okay, so they give you the mass of potassium, but they ask you to find the mass of potassium oxide. So this type of calculations, we need 3 steps. Okay, 3 steps. 3 steps. The calculations involve the equation 1. Okay, we need 3 steps. So first step is to find the number of mole. Why we need to find the number of mole? Because we are relating the reactant and the product by using the number of moles. For example, 4 moles of potassium produce 2 moles of potassium oxide. So the relationship, they relate it by using the number of moles. Thus, we must find the number of moles. So here, the first step, we find the number of moles. Okay, number of moles of potassium. Potassium, because we only have the information for potassium. Now, you have the mass. How to find the number of moles? So from the equation just now, mass is equal to mole times molar mass, this one. Okay, mass is equal to mole times molar mass. So mole will be equal to mass divided by molar mass. Okay, molar mass. From here, mass is equal to mole times molar mass. Thus, mole will equal to mass divided by molar mass. So the mass here, it must be the mass of potassium, and the molar mass here, it must be referred to the molar mass of potassium. Okay, the mass of potassium is 19.5 gram. Okay, and the molar mass for potassium is given in the question. Molar mass is atomic mass. Atomic mass also means the molar mass. So the potassium is 39. So 39 gram per mole. Okay, this is the molar mass. Okay, now 19.5 divided by 39, you will get 0.5 mole. Okay, 0.5 mole. Gram and gram you can cancel, so you get mole, 0.5 mole. This is the first step. Second step, you need to relate them by using the number of mole. So from equations, okay, from equations, okay, 4 moles of the potassium will produce 2 moles of potassium oxide. Okay, 4 moles of potassium will produce 2 moles of potassium oxide. And then just now from the calculation, you get the number of moles for potassium is 0.5. Okay, thus 0.5 moles of potassium, it will produce how many moles of potassium oxide? So how you count? Okay, you're using the method we call darab silang. You 0.5, you times 2, okay, and you divide it by 4. Okay, then you will get 0.25 moles, okay, of potassium oxide. Now you have the number of mole for potassium oxide. They ask you to find the mass. So we go back to the formula just now. Mass is equal to mole times molar mass. So now we want to find the mass of potassium oxide. Mass is equal to mole, okay, the mole here is refers to the mole of potassium oxide times molar mass, okay, molar mass. The molar mass here also refer to the potassium oxide. Now, the number of mole of potassium oxide you already get at the second step here, 0.25. You just substitute inside 0.25 mole, okay, time molar mass of potassium oxide. This one you need to count, okay. So we count the molar mass of potassium oxide. So what is the molar mass of potassium? We refer back to the question. So they give you relative atomic mass. Remember, relative atomic mass also means molar mass. Only the difference is relative atomic mass, it has no unit. Molar mass, it has unit. The unit for molar mass is a gram per mole. Okay, but the value is the same. Okay, so molar mass for potassium is 39. 39. Okay, you have 2 potassium. Okay, you have 2 potassium. So times 2 plus oxygen. The molar mass of oxygen from the question is 16. Okay, 16. You will get 94. Okay, gram per mole. Okay, gram per mole. So 94 gram per mole. You substitute inside the equations, and then you will get 23.5. Mole and per mole you cancel. Okay, the unit, then you get gram. 23.5 grams. So the answer is C.